So how would we use this dumbbell to work out how heavy Hasbi is?
Well, if we move around the weight until the seesaw becomes balanced, we can then write down that anti-clockwise moments are equal to clockwise moments.
Like a moment in time?
No, a moment is like a turning force.
Look at the kettlebell, kid. Its weight is trying to turn the seesaw anti-clockwise.
And this means there is an anti-clockwise moment here.
How would you work it out?
If we draw a line from the pivot point to the force, the moment is defined as this distance,
We'll call that D1.
multiplied by the size of the force acting at a 90-degree angle to that distance line.
And we'll call that F1.
And same for the other side. Clockwise moment is the distance from the pivot
D2.
times this perpendicular force.
F2.
What now, Dana?
Well, Isaac Newton said the force of an object is its mass times its acceleration, or F equals ma.
The mass of the kettlebell is 30 kilos, so its force is its mass 30 times its downward acceleration, g.
And we can put down Hasbi's weight force as his mass, the letter M, times G.
Wait, what's G again?
Remember, the Earth's gravity is always trying to make everything accelerate towards it.
And when we're on the surface, that acceleration points downwards, and that's what we call G.
It's about 9.8 meters per second squared.
So now if we measure the two distances and then plug them into our equation, we can now rearrange this to get M Hasbi's mass in kilos.
Can you divide both sides by G?
Yes, and we can also divide by 2.
Okay, our 1 times 30 divided by 2 is 15.
So it turns out Hasbullah is 15 kilograms, which is about 40 pounds.